So let's first start about why there's a need for surface treatment. The image on the right shows both treated and untreated surfaces. The top portion that you see untreated, the drop of ink in this case stays as a drop of ink and is raised above the surface. This is what will typically happen when you try to print on a surface, likewise coat or bond to a surface that is untreated. The ink or adhesive acts very much like a droplet of water on a freshly waxed car. It beads up and rolls off the surface. When you surface treat the product that you're looking to adhere to, the ink, adhesive, coating tends to lay flat or wet out, as we call it, on the surface. This allows you to get the coverage you're looking to achieve on your product. The image on the left of the dog is a perfect example of this. The top half of the image has been treated, while the bottom half has not had surface treating applied to it. You can see the ink lays down and the image is clear on the top, where it's blotchy, and you can actually see the droplets of ink on the bottom. So in addition to improving adhesion, there are many other benefits that our customers see in using surface treating technology. Sometimes it will eliminate other processes that they use to enhance adhesion. It can eliminate hazardous chemicals such as primers. There's a component which reduces the cost of both materials, inks, coatings, or adhesives. Equally, if not more importantly, it's going to improve your product quality as well as likely improve the productivity of your operations. So now we know a little bit about surface treating. Let's talk about why things sometimes don't stick to the product. So there are various factors affecting the success of adhesion on your product. Some of the dynamics include material type. Different materials, say polyethylene, maybe polyester, PEEK, ABS, they're all going to have different characteristics to them and bondability as they are in their raw form. We're going to talk a little bit more about this as we move on in the presentation. Additive loads can affect them as well. The initial surface chemistry or surface roughness, two things we're going to talk to more again as we progress here through the presentation. The adhesive chemistry, whether it's the chemistry of an actual adhesive, an ink, whatever that may be, that also affects adhesion success, as well as bond stress. There are a couple impediments that also come into play. The first is kind of an inherent low surface tension, or as we may say, we may talk about surface tension and surface energy kind of in the same vein. But what we're really talking about on most plastics is that we have non-porous or inert surfaces. In layman's terms, think about it. It's a slick, shiny surface. And those are surfaces which tend not to absorb ink, an adhesive, or a coating. Unlike, say, a product such as newsprint, when they print a newspaper, surface treating is not required because the ink will absorb into the paper. Material additives and release agents also provide another dynamic to your printing, coating, and bonding process. With these additives and release agents, they tend to bloom to the surface and create a barrier to adhesion. Finally, surface contamination such as dirt, grease, oil, dust will also impede adhesion on your product. Now that we know a little bit about impediments to the treating process, let's talk about ways that we can promote adhesion with surface treating. The surface treating process is going to do three things. It's going to clean the surface, it's going to micro-etch the surface, and it's going to lay down functional bonding receptors to the surface of your material. And the best way to explain this is really with a visual. So what we're seeing on the screen now is if you look on the left-hand side, you're going to see the lower side is what would be illustrated as a contaminated surface. The surface treating process will first clean the surface. So we're cleaning any contamination off of the surface. That provides a minimal surface area in which you can bond to. As we're progressing through the surface treating process, we start to optimize that by micro-etching the surface. This is similar to, say, applying a sandpaper to a surface to roughen it to enhance better adhesion. Maybe you've seen this at home before when you're trying to glue two pieces of plastic together. In addition to that micro-etching, which is not visible to the naked eye, we're also creating receptor sites, and we're changing the chemical nature of the surface to enhance adhesion as well. What you're going to see on the two pictures we have here is on the left what a non-treated flexible film product may look like. And you'll see that by and large it's pretty uniform, fairly smooth. After being treated, you can see the image on the right looks significantly more rough, and that is providing the additional bonding sites we need to enhance adhesion and have successful printing, bonding, or coating to your product. So in summary, we're going to clean, etch, and functionalize surfaces, and this ultimately improves wettability. The picture on the right is an illustration like we saw before with the dog picture. On the right-hand side, an untreated surface where ink will bead up and not wet out, as we'll call it. But on the left-hand side of the picture, you see a treated surface where the ink has actually wetted out and lays down flat across the surface, ultimately providing the image you're looking for or a much improved bond to your product. I'd like to hand it over now to my colleague Sarah Bauer, who's going to talk a bit about the different technologies that's used in the surface treating process.
Thank you, Ryan, for the overview on plasma. I'm going to switch gears a little bit here and dive into the differences between the different types of plasma, both air plasma, variable chemistry plasma, and flame plasma. I'm going to start by discussing what exactly air plasma is. When air is ionized, the electrons collide with surfaces to break molecular bonds. In this slide on the right-hand side, you can see two examples of what air plasma is, both a blown arc and a blown ion plasma. I'm going to start by talking about the blown arc plasma system. This particular type of technology is really great for treating non-conductive materials. For pad printing, labeling, coating applications are probably the most common. You can see here on the bottom right-hand of your screen an example of the blown arc plasma system treating a toothbrush for a printing application. So if you can think of where next time you're at the dentist and get that free toothbrush, you'll look down at that print and maybe think a little differently as to how that ink actually adhered to the toothbrush. Another nice thing with this particular type of technology is that it has a very nice wide treatment pattern. It can treat anywhere from about 2 inches to 3.5 inches wide and comes in multiple head options, which is nice as well. One of the biggest benefits of using a blown arc plasma system is the utilities. All you need is 120 or 240 volt electrical to run it. It has an internal blower, so you don't need to hook up any kind of gas or air line to it in order to create that blown arc plasma discharge that you see. The other type of the other type of air plasma system that we manufacture is a blown ion plasma. The blown ion plasma's benefits are that it can treat both conductive and non-conductive materials. And as you can see here on the picture, it has a very focused treatment coverage. It treats up to about 5/8 of an inch with a single head system. With that precise treatment pattern, you can see, for example, here we're treating a plastic component for adhesive bonding. But the nice part is you can also integrate this on a robot. It can be used for a lot of contoured products that have a very specific glue or print path involved in the process. And another very nice feature of the blown ion plasma system is that it can treat at a fairly high line speed. Typically, you're looking at speeds 50 feet per minute or up from there, depending on the application we're working with. Its utilities are also 120 or 240 volt electrical, but it also uses compressed air to create that very high velocity discharge that you see coming out of the head. Another technology that you can consider is a variable chemistry plasma. The reason why you might go towards a variable chemistry plasma is if you're working with what we call a difficult to treat surface. An example of this would be a fluoropolymer, a Teflon material. By nature, those types of materials don't like things to bond to them, whether it be an ink, an adhesive. It's designed for things not to stick. So in order to get good adhesion, we do need to actually create more functionalization on the surface that Ryan talked about earlier. It's more than just the cleaning and the micro-etching. Functionalization is really important with this system. As you can see here on the right-hand side, there is two different discharge heads. There is one that looks a lot like that blown arc plasma system we discussed, where it's an atmospheric, about 2-inch wide treat. But we also can do some customization. On the bottom right-hand side of your screen, you can see that there's actually a wire going through what looks almost like a chamber. We can treat different types of wire in cable or sheets, glass, different types of substrates that are flat, and customize it to your application. Another nice use with the variable chemistry plasma system is that you can use this in a lab. If you are considering purchasing or looking at something for a lab for your facility, the nice thing is you can use different types of noble gases in the mix to basically get different types of results. So this is a very good lab system to look into. The utilities are compressed air to create that discharge that you see on the screen, noble gas, or gases depending on your application, and then 120 or 240 volt electrical. One very common question we get is, what is the difference between a propane torch and a flame plasma system? A lot of you may have even tried this before, where you wave a propane torch over your part. You get some adhesion benefits, but then you start to think, okay, how is this actually going to work for production? There's really three pieces I'd like to point out, and I'll dive into the details of the flame plasma system. It is, by going to a flame plasma system, it is of course safer for both you and your employees. It is consistent, so it's not subject to human error, and it's a very controllable gas mixture that's coming out of the head. The flame plasma system ionizes a gas mixture, so that could be natural gas or propane. You can see a photo of this on the right-hand side of your screen, where we're actually treating a plastic container, and you can see there's actually two heads being used to treat both sides for a labeling application. The benefits of using flame plasma is that you can treat at fairly high line speeds, typically in the 75 feet per minute and up from there. You can treat to much wider treat areas, so maybe you're thinking of a product that needs to have about 10, 12 inches of treat width versus some of the smaller pattern systems that we've already discussed. This would be a really good alternative. It's also very long lasting, so while we always recommend that you treat as soon to your bonding process as possible, if you do have a situation where you do need to treat and have it longer lasting, flame plasma is probably going to be a good application for you to look at. And one of the most important parts as to why you'd look at a flame plasma system is that it can treat multidimensional surfaces. The gap between the head and the product is very forgiving with the flame plasma. We'll talk a little bit about that at the end of our presentation of what that is. But anything that has lots of contours to it, maybe you need to get inside of an area that's very difficult to reach, a flame plasma system is going to work great for you. Utilities, once again, natural gas or propane, air, compressed air, and 120 or 240 volt electrical. So at this point you might be thinking, how does inline surface treatment compare to the other surface preparation methods out there, and how do I know which one is going to work for my application? There are three alternatives to using an atmospheric plasma. One would be a liquid primer or a solvent. The downsides to using this is it's the cost. Obviously there's a consumable. It can be very hazardous to employees in work environment. There can be cleanup. I'm sure you've all experienced that from time to time. And of course, it's a consumable, like I mentioned. There's also mechanical preparations. Ryan referred to using sandpaper or something to that degree to roughen a surface. So think of sandblasting or skiving if you're working with a folding carton application. That is an alternative. The downsides, obviously, there's wear parts, and it can get very messy and time-consuming. And then the third alternative is a vacuum plasma. Same use of this technology, but for those of you who are not familiar with vacuum or chamber plasmas, this is a type of system where you actually have a chamber, think of an oversized microwave, where you put in a part, shut the door, turn it on, and you're actually using some consumables, noble gases to treat the parts. The downside to this is these particular systems are very costly as far as an initial investment, and there's consumables involved as well. And the biggest downside is that it's a batch process. It doesn't allow you to keep your line and process moving, and you do need to stop and put the parts in and shut the door and move on from there. So these are a couple questions when you start to look at atmospheric plasma that we typically ask to point you in the right direction. First is, what is the material that we're working with? Is it conductive or non-conductive? As we discussed earlier, that's very important. What's the area that needs treatment? Is it a fairly small area? Is it a large contoured part? How is the part handled? Are you going to be using this just in a small volume by hand type environment, or will this be on a robot? Of course, what is your speed and cycle output? We want to match what you're currently using. We don't want to slow you down by any means. So we need to understand, how fast do you need to treat the parts or part, and then the volume. And then taking all of the answers to those questions, we then put it to test in our lab. You can see a couple photos on the right hand of your screen of the different systems running at the same time. We do have a lab here in Enercon, and I'll talk about that a little bit later in the presentation if you are interested in pursuing one of these technologies. Here is just a quick snapshot, and by no means not all the materials that we've worked with, but very common materials that we work with at Enercon. You'll see the material, the initial dyne level, and dyne levels are, for those of you who are not familiar with what a dyne level is, it's a measurement of surface energy. It's something that you can use dyne pens or dyne solution. In the left-hand column, you can see that what the initial dynes are, typically fairly low to mid-30s of that particular material. And then on the right-hand side, you can see the post-treatment dyne levels. These are dyne levels that we've been able to treat to using different types of technologies. For those of you who have more questions about dyne levels, feel free to connect with us after the presentation. We'd be happy to go through it in more detail. I'm going to pass the mic back to Ryan, who's going to talk a little bit more about the different industries that use surface treating.
Thanks, Sarah. So let's dive in a little bit and talk about some applications which use surface treating. So one which uses it quite often is packaging and decorating. This could be everything from maybe a bottle which is pad printed on, screen printed on of some sort, or a screw-on closure for a consumer package, maybe printing on the top of the closure. It could be for label adhesion on a package, whether it's a bottle, maybe a clamshell of some sort. Any sort of packaging or decorating needed to be done on a product, maybe a promotional item. Folding cartons is a big area that we've seen some great success with surface treating technology. And with folding cartons, it will typically be not just standard paperboard cartons, but they will be coated paperboard cartons. And oftentimes with the coated paperboard cartons, they are using some sort of mechanical roughening, such as skiving, to take that coating off the glue flap. With surface treating, we're able to replace the skiving, which is a bit of a messy process, with wear parts on it as well. And what we found is that oftentimes the bond strength becomes so great that if a folding carton is a secondary package, you may be able to remove the primary package. We actually had this in a food product where the company was able to increase their glue flap strength and eliminate a primary package and use the folding carton itself as a primary package. Medical applications abound. There are countless numbers of these. It could be everything from enhancing adhesion to print on the side of something. Many times it is used to enhance a coating on a product. It could also be used for needle hub bonding in syringes. The nice piece with medical is that we have an application like these blow-in ion systems, which are pinpoint precise, allowing you to get into the small areas typically common in medical applications. Automotive and aerospace applications are some of the really cool applications that we see. The image that you see here is actually a robot and flame treating cell for the dash panel of a new car. What they're doing in this case is after the dash panel is molded, they flame treat it, which takes all the contours of the dash panel itself and then paint the dash panel. Likewise, you may have a dash panel on a higher-end car where they actually wrap it in leather or some other sort of material, and they will inject a foam between those two. To enhance foam adhesion there, they use surface treating as well. It can be used door panels on cars for foam applications. It can also be used in the headlamp of a car where we'll actually trace the glue track to get better bond adhesion between the front and rear pieces of plastic on a lens or a light for an automobile. Similarly, with materials, exotic materials in the aerospace industry, bonding is usually a challenge, and we have a number of applications which has helped enhance these bonding applications. One which has actually been there that we've seen potting of cables is one that has been a piece. So if you're trying to bring cables into a plastic component and use a potting compound to get better adhesion, we can treat the plastic component to ensure they have proper adhesion and those pieces don't fail in the aerospace industry. Talked a little bit about wire and cable as we talked about the aerospace industry, but if you've ever picked up a piece of wire, maybe gone to Home Depot or Lowe's or your local hardware store, picked up a piece of wire and seen the marking on it and been able to rub it off with your finger. This is a common problem that has been in that industry. By using surface treatment, we create a great bond between the ink that is used when printing on the cable itself, so those markings do not come out. Similar to wire and cable, we've actually seen a bit of this in the pipe industry, where inkjet printing is used on the pipe. We enhance adhesion through surface treatment in that industry as well. Here's a quick overview of the systems that we offer. We have our Dynamite IT and IT Elite systems, which are our blow-in ion systems. The Dynamite HP, which is a blow-in arc system. The DynaFlame in the center bottom is our flame system. And our Plasma 3 and Dynamite VCP are variable chemistry plasma systems. These are all systems. Your application may be fit for one system. It may be fit for more. That's a good conversation to have with our application specialist here to get you the system that might be right for your application. Now, Sarah's going to talk a little bit more about how we can integrate these treatment systems into your application in the field.
Thank you, Ryan. So with the past few slides that Ryan just went through, you saw the different types of plasma treating systems integrated in lots of different ways. Like we mentioned before, you can integrate it offline. Offline would be perhaps a small batch application where you just maybe need to treat a few at a time. A simple conveyor with a head mounted in line would be perfectly acceptable to use the system for. Or maybe you're using it in a lab and you simply are just using it from time to time. Offline is perfectly fine, and there's lots of ways that you can do that. Please ask us. We can give you some tips on setting it up for lab use. over a conveyor or your existing equipment. We mentioned before that our goal is to keep you moving at the speed you want to move at. We don't want to slow you down by any means, so actually putting a lot of these systems right in line is fairly easy to do. You can also use it with an indexing system. All of these systems can be cycled. They can also be used on a turntable. On the bottom right-hand corner of your screen, you can see that one of our systems actually being integrated on a pad printing line. We also have a photo on the right of a robotic application, another way to easily use the systems. But really the key point I want to point out here is when you're thinking about how do I integrate this, is that this system, actually all of these systems, are going to talk with your current line. They can be cycled on and off. They will communicate with them to both start and stop with e-stop and basic operating controls. And some of our systems have some functionality where they're actually doing more process control and be able to give you more feedback of what's going on, depending on what your application and process needs are. I'm just going to go through the systems briefly here to talk about proper setup, because setup is extremely important to the success that you will have with any of these systems. So to start with, you can see a photo here. This is replicating what a Dynamite HP, that's the blown arc plasma, and the Dynamite VCP, that's the variable chemistry plasma, would look like. The two things that affect your treatment are both gap and speed. The gap that needs to be set between the head and the item that you're treating needs to be somewhere between 3/8 of an inch to 5/8 of an inch away. We call that the sweet spot. The speed that you'll be looking at typically with these systems is anywhere from a foot a minute up to approximately 20 feet per minute, give or take the application, give or take a few feet per the application. The blown ion plasma, or the Dynamite IT system, that's the one that you saw treating the medical device a few slides ago. That system needs to be between about 1/4 of an inch to 1/2 of an inch away between the tip and the product. Speed, I mentioned briefly earlier, you typically want to start about 50 feet per minute or so and go up. Depending on the application, there are some top speeds that you'll want to consider, but normally they're pretty fast. We're probably talking 300–400 feet a minute before you start to top out with this particular system. So for the most part, that'll fit most applications out there. The DynaFlame system, or the flame plasma that we discussed, actually comes in two different burner styles. And so I have a photo of each here up for you. Ryan mentioned and showed you a photo of the car part being treated on a robot. The photo on the left is our 226 series burner. This particular burner is designed for robotic use. It is a higher velocity burner that can accommodate faster line speeds or the jerking that kind of goes on with a robotic application. We want to prevent any kind of waving that could occur with the flame moving at a high line speed. We don't want your part to not be treated from edge to edge, so we've designed this burner for that application. And then the burner on the right-hand side is our standard burner. This is really good for any kind of an application where you'd be using the burner in a stationary fashion over a conveyor where the burner would not be moving. The gap, I mentioned this a little bit earlier when we were talking about flame, but this is really the key features to why you'd want to look at a flame system. It's a very forgiving gap. You can be anywhere between about 1 to 4 inches away, depending on the product we're working at, with a lot of medical devices, a lot of automotive parts. Really great for this because we can get into areas that maybe need to be potted, parts that need treatment in one part, not another. It's really nice to kind of get in and around areas that the other systems just can't simply reach because their gap is so much more specific. So if you are thinking about using this for something that is very contoured, please consider the flame because it can be quite a cost savings by using that versus some of the alternatives to atmospheric plasma treating. Well, sometimes we do have some problems. If a customer comes back to us and says, hey, this has been working, but all of a sudden it stopped. What's going on? We'd like to point this out in our webinar here today because you may be actually using plasma at this time and have come across some bumps along the way, and we want to point out some questions to ask to help narrow down what that problem is. The first question we always ask is really what has changed. If plasma was working and all of a sudden it stopped working, you're not getting the bondability you want, or your pull strength, or your ink is rubbing off. Things we want to check. One is the gap in speed. Those are the slides that we just went through. Has that changed? Has an operator bumped the head and it's no longer within that sweet spot? Have you increased or decreased your speed of production? Environment and handling is also very important. We alluded to how oils and contaminants can really affect the surface for bondability. So are the parts sitting in a very dirty environment? Is there more handling by your operators involved versus when we first set up this plasma for you? If so, sometimes that can be the culprit. A fingerprint is very much a detriment to adhesion. Another thing to consider is the material. This actually is probably the most common culprit that we come across. Have you changed your supplier? Say you're working with a polypropylene injected molded part and all of a sudden the polypropylene is coming from a different supplier and you're not getting the adhesion you need. Sometimes there's other things that are mixed in with that polypropylene that really affect what's going on. Another would be mold release. Is there additional mold release on the part that wasn't there before? That can really affect your results. With all of these, we can use Dyne pens or Dyne solution to test our surface energy. We talked about that slide earlier with the different measurements that can be taken. It's one way to kind of help troubleshoot what's going on and if it truly has changed as far as incoming surface energy goes. And then, of course, it is really important, where at all possible, is to treat in line directly before the process. You really do want to eliminate the time between treatment and bonding, so it's printing, coating, labeling, as much as possible, because with any type of surface treatment, it is going to wear off over time. So you do want to eliminate that time period as much as possible. That being said, another common question we get is how long does the treatment last? We would call that the million-dollar question, because really treatment will vary. It varies depending on two things, really. One is the material we're working with, and one is the type of technology that we're working with. But time is the enemy. It can vary from hours to several months. The only way we can really narrow down how long the treatment will last is to actually set up a trial and do a longevity test for you. Shared that some of the culprits, the materials that tend to drop their surface energy very quickly, are anything that's a very pliable plastic, maybe something with plasticizer in it, or very bendable. Those tend to be the most difficult to treat for longevity. The harder plastics tend to hold surface energy the longest, but regardless, we do recommend that you do a longevity test to confirm what that window of opportunity is. It's always good to handle the parts as minimal as possible with clean latex gloves whenever possible by your operators. Storage is never recommended. You just don't know what kind of results you're going to get if you do treat and store a part. It's good to do everything in line. And of course, no surface treatment is permanent. It may take a very long time to wear off, but it will wear off over time, unfortunately. So that's why we do want to set up that treatment right before bonding. So with all of that said, how can we help you? Maybe you have a current project that you're working on. Maybe you're currently using plasma and you're having some difficulties, or maybe you're just interested in the technology behind it. We have a full-time sample laboratory. Enercon is located in Menominee Falls, Wisconsin. That is just north of Milwaukee, pretty much a suburb of Milwaukee. You are more than welcome to come visit here at Enercon. We very much welcome guests in our building. But of course, we understand not everyone can visit, so we also can arrange for trials to be ran and returned to you for evaluation as well. We also have consignment and demo systems available too. We have local representatives all over the world to support you if need be, or we can send you a system directly here from Enercon to borrow. It's our goal to help you find a solution and make sure that whatever system you do decide to go with, that it's the right system for your application. And of course, we have plenty of application experts and engineers. So maybe you do have a product that is unique. Maybe you have some unique requirements. Please feel free to give us a call. We'd be happy to chat with you, see if we have something available, or if we can, of course, customize something for you as well. Dedicated sales managers. I am a sales manager here at Enercon. I have quite a few colleagues that work right alongside me to be available to you at any time, whether it's a new or existing application. Feel free to call. And then, of course, 24/7 service and support. If for any reason you are experiencing some difficulties in the middle of the night and need support, we do have a line here at Enercon. You can call and speak to someone here right out of the Menominee Falls, Wisconsin location to help troubleshoot you through your process, because we understand what it's like to be down at third shift. It's very difficult. And we understand how important your time is as well. So I'm just going to kind of quickly go through a review of the presentation today, and then we will turn it over to questions. Surface treatment promotes adhesion by cleaning, etching, and functionalizing the surface. Those are the three things that plasma does. We can help you eliminate liquid primers and mechanical preparations. Our goal is to increase your bond strength, reduce your material cost, and improve throughput. We can integrate plasma with robotics, conveyors, indexing, and many other automated processes. And of course, we have a wide variety of applications and industries. Here's just the sampling, but by no means is that all-inclusive. Please challenge us with a new industry. We love new projects here at Enercon. There are three different types of atmospheric plasma: air plasma, variable chemistry plasma, and flame. Of course, proper setup begins with the correct air gap and dwell time, and of course that translates to line speed. It's always ideal to treat immediately prior to your printing, coating, bonding, labeling, painting, whatever application you're working with. If you are experiencing some troubles, always begin with the question, what has changed? And lab testing is available to you and help identify which technology will be best for your application. We are going to open the floor up now for questions, so please keep submitting them if you haven't already. As we discussed, we will get to as many as we can here in the next 20 minutes or so, and if we don't get your question, we will follow up with you after the presentation. So please keep submitting them. We'd be happy to help. I'm going to turn the mic over to Ryan, and Ryan is going to answer the first question that we have here on our screen.
Okay, the first question we're going to tackle is, what is the difference between corona treatment and plasma treatment? That's actually a really good question, and a pretty easy one to answer is many times the terms are used interchangeably, but there can be a difference. So let me explain that. Corona is technically a plasma. So in the industry, most of the time, you'll see corona treatment and plasma treatment interchanged. However, you'll look at items such as variable chemistry plasma, which is different. And that is sometimes referred to plasma treating in the flexible side, where a gas, an inert gas, is added to a corona treating process. It's not as simple as just adding it to the process, but essentially that's where plasma treating may be a little different than corona treating.
All right, I'm going to answer another question here. Do we have any experience with trials with removing oils or lubricants from steel sheet in coil form? This is actually a really good question. Since plasma does clean the surface of substrates, there is a certain level of contamination beyond just dust that we can remove from the surface. We have been successful, especially working with metals, where we're actually removing the machining oils from it in lieu of perhaps an IPA wipe or something else. That being said, it really does depend on the level of contamination that you are working with. So the best way, if you are interested in looking into this further, the best way for us to determine if we can do this is to either, one, set up a lab trial with Enercon, or two, we'll have someone come in with a demo system for you to try out right in-house for your application.
We've got a couple of questions that are relating to width. One of them is, are you able to treat a 40 to 60 inch wide web? The answer to the question is yes, absolutely we are. We have a number of different technologies, and treating webs is one of them. We can do everything. We make systems as small as 10 inches wide and have gone to multiple meters wide. I think we've probably made 5, 6, or 7 meter wide systems at one point in time. So any width is something we can do from a web perspective. Another question relating to width is, what's the widest area you can treat? And I'm guessing that this question is relating more towards objects, not flexible materials, but objects. So we have various width units for treating objects. We can do everything from as small as 3/8 of an inch wide to we have flame systems, standard flame systems, which will treat up to about we've got flame systems that will treat up to
about 16 inches standard. But that being said, we actually can customize flame systems really up to any width you need. Our standard goes up to 16, but beyond that, I mean, we can do 5 meters wide if you want. There's really no limit to it. Typically, when we're working with a very, very large object, one thing that we have customers consider is to utilize the flame system on either an XY kind of robot table, or if it's a contour part, something a little bit more elaborate. We can, if you are working with a fairly large part, then feel free to give us a call, and we can kind of give you a cost comparison of going with one versus the other. But there's really no limit to how wide of a treat width we have.
The other option that you have is all the systems that we talked about today and the widths we talked about are typically with single head systems. We also make dual head systems in pretty much all of the systems that we manufacture. So if you see a system that says it has a 2.5 inch treat width, with a dual head system, that can easily be a 5 inch treat width as well.
All right, I'm going to answer another question here. The question is, can your lab determine what an unknown product material is to help select the best treatment? So how we can help you is, if you don't know what the material is, that's okay. We can start really with a very broad DOE and work our way down to what's really going to work for your application. Unfortunately, we don't really have a way to help you determine what the material is. We could probably give you feedback as to is it conductive or non-conductive. We can give you feedback as to its surface energy, both as it comes into our lab and also after it's treated. But it's okay if you don't have all the details to what the material you're working with. We understand sometimes all we know is that it's a plastic component and we need to bond to it. So don't feel as though you need to have all the answers when you call into Enercon as to what you're doing. Really, what we need to know is those questions we went through. How fast do you need to go? What area needs treatment? That's always very important. And obviously, what is your application? Are we applying adhesive? Are we putting an ink on or a coating? So that's all right if you don't have all the answers. We'll help you find a solution.
All right, we've got another great question surrounding the operation of systems. How much does it cost per square meter to treat using plasma systems? Great question, one that we actually get quite often. And the beauty of many of our systems is the cost is pretty minimal to treat your object. We're typically talking about The costs for our blow-in ion and blow-in arc systems are simply the electricity that is used to run the treater, as well as any compressed air requirements. So that being said, those are fairly low. When you get into a flame system, you're obviously going to add the cost of natural gas. Beyond that, it's really compressed air and electricity, and it really uses a small amount of electricity on that system. And if you're looking at one of our variable chemistry plasmas, you do then introduce a gas or a mixture of gases into the equation. So your cost does go up in those cases, but many times we are able to treat with one of our, I'll say, more standard blow-in arc, blow-in ion, or flame plasma technologies.
Great. So I'm going to answer another question here. Just taking a look. So one of the questions we have is what kind of gases you can use in a flame system. Currently, the only two gases that can be utilized are both natural gas and propane. Right at this time, we don't have any other gases that can be used with those particular systems. But that being said, if you are looking at bringing in a specific kind of noble gas into the mix, maybe you've qualified it in the medical field or you know that you've had success in the past, we highly recommend that you look into our variable chemistry plasma systems. Feel free to give us a call on that one if there's something very specific, and let us know what your specifications are.
Sarah, here's an application question for you. Does plasma have beneficial effects on composite materials such as carbon fiber?
I'm assuming what they mean from beneficial effects is that we're able to treat it, unless there's something else that this particular attendee is looking at. But I guess we'll first answer this question: can we treat carbon fiber? The answer is yes, we can treat it. There's a couple different systems that we could look at, both the Dynamite IT, blown ion plasma, as well as the flame plasma system. Of course, it would depend on what kind of speeds and size that we're looking to treat. If there's other beneficial effects, sometimes customers are looking for something that is not an adhesion application. Maybe you're looking to dull or perhaps shine the surface. Maybe you're looking to remove something. It has nothing to do with bonding. So there are some other applications out there that are beyond just bonding. Feel free to call us on that one because, to be honest, the best way is to do a trial and error on it. We won't know until we try it out. And we have, because of trials, have been able to find alternative solutions for customers that, like I mentioned, have nothing to do with adhesion. I'll give you an example. Sometimes customers need to remove the flashing from a molded part. It has nothing to do with putting ink or adhesive down. It's simply that it needs to be removed from the part to get rid of that on the edges. The flame plasma system is actually very, very good at that. So that's just one example of some other applications we've come across.
We've got a question that says, please elaborate on dyne level and how it is measured before and after surface treatment. It's a great question and a great thing for every user of a surface treatment system to know how to do. Dyne level is essentially the measure of surface energy or surface tension of the product you are looking to treat. The best way to measure dyne level is to use a dyne solution and a clean, sterile cotton swab. And you can place the dyne solution on the cotton swab and draw it down against the material you're trying to treat. What that will do is, if it is properly treated, that dyne solution is going to be at a certain level. You are going to have solutions that range anywhere from a level of, let's say, 30 on up to, when you get up to a level of water wet, is 72, correct, Sarah?
72 dyne, yep.
So you'll,
distilled water.
You'll have levels that go in between that 30 on up. So the slide earlier in the presentation showed normal materials with their initial dyne levels. So if you refer back to that slide as the PDF or these slides come out, you'll see that many materials start in the 30s. And Sarah, what would you say? Most materials, if we get them into the mid-40s, we start to see success in adhesion?
Yep, depending on the application, typically mid-40s and higher are where we see our success rates. It's really going to depend on what you're applying to the surface. Sometimes we need a little higher, but in most applications we can treat mid-50s and higher. It's rare that we aren't able to get to that level. There are some of those materials, such as discussed, the fluoropolymers, that are more difficult, but in general, yeah, we're able to treat much higher than your actual needs are.
Right. So you're either going to use a dyne solution, which admittedly is a bit messier process. There are also dyne pens that are available, and these are usually a good indicator. The only challenge with them is that once you touch them to the surface of a product, they then may become contaminated. So they aren't quite as accurate, but they usually give a pretty good feel for the success of treatment or the successful dyne level measurement of that, both pre and post-treatment. You want to check both before you treat and then after you treat to see where you've gotten.
Sure. Yeah, and just to kind of piggyback on that, some of you may be familiar with contact angle. Contact angle is a measurement that's taken with a water droplet on the surface of material, and then basically you take the angle between the material that the droplet is on and the actual droplet of water. Our goal is, obviously with surface treatment, is to get that water to wet out on the surface or decrease that particular angle as much as possible. This is a really easy way to measure if you do have a contact angle meter. I will note, though, only if you're working with a flat, completely flat surface is this a good measurement. If you are working with a three-dimensional object, dyne solution is really your go-to for surface energy measurement because you can't get an accurate reading from a contact angle. But I just wanted to point that out there because some of you may be familiar with that type of measurement system.
Sarah, one other question here is, will dyne level or surface energy readings guarantee or ensure, is that the only test to whether you're going to get proper adhesion?
That's a great question. I would love to say yes, but that's not the correct answer. Dyne level is really only an indicator for adhesion. It's only an indicator in the sense where we can see how we are changing the surface energy of the product that's being treated. That being said, there are cases out there, it's less common, but it does happen, where we either, one, don't see a change in dyne, or two, we do change the dyne, but if we don't see a change in dyne, the customers sometimes can still get good adhesion. If we do change the dyne, sometimes they don't get good adhesion. At the end of the day, to be very honest, the best way, and truly the only way to determine if you're getting the adhesion you need is to treat, and then of course go through your process and do the appropriate testing procedures. But dyne testing is, more often than not, somewhat of an indicator as to what kind of adhesion you're going to get. I also note, too, dyne pens are great for quality control for operators. They're very easy to use. And we do have a link on our website if you are interested in learning more about how to use dyne pens and if you are interested in purchasing them, because they're a great way to kind of see where you're at and where you need to be. And you can easily give, let's say, an operator a 50 dyne pen and know, hey, we need to be there.
Sarah, there's a great question that just came in. I have heard about materials being over-treated. At this point, adhesion drops off again. What can you tell me about this?
Over-treatment is something that can happen. It's a common misconception that the more surface or more dwell time you have on a product, let's say you take a blown ion plasma and run it past a part 10 times, the higher the dyne level, the better the adhesion. Unfortunately, it is not quite the case. When you are using a plasma treating system, you're cleaning, but we also mentioned functionalizing. You actually start to damage the part at a molecular level after a while. So if you're running maybe too many passes or too slowly for the type of technology, what happens is it brings that dyne up, but it actually starts to bring it back down. So how you could test for this is a simple changing of the speed and actually getting that range. We talked about that being very important for gap, but it's also very important for speed. There's going to be a minimum and a maximum speed really for any type of technology. That's something that we can help with in the lab, or is also something that we ask when you are going through those troubleshooting tips. Is there something of the process that's changed? So please be aware that it is a phenomenon. It does happen, not in all cases, but you can overtreat a product.
All right, we are coming up on the hour mark. Sarah and I are going to stick around and continue to answer questions, but I did want to let you know that within 24 hours, this webinar recorded will be available on Plastics News website, plasticsnews.com/webinar. We look forward to answering more questions. If there's things that we don't get to today, we will definitely reach out to you. Feel free to call either Sarah or I or anyone here at Enercon to answer these questions. But if you do need to jump off, feel free to do so. We're going to continue to answer questions for the next few minutes here.
All right here. So I'm going to add another question just came in here, and I'm going to put that out there. Can your products, such as plasma treatment, to be used along with primers or other adhesion-enhancing treatments, especially for difficult applications? So I guess the question we're looking at is, can you use treatment and a primer at the same time? Is it going to be of any benefit? That's a very good question. One thing I'd like to note, and we do get this question a lot, is when you're currently using a primer and looking at using plasma, sometimes the thought process is, let's plasma treat, let's put some primer on, we're going to have double the treatment, and this is going to be great. The only downside, really, to using something, it could be a primer, it can be an IPA wipe, it could be really anything, putting something on the surface after plasma treatment is you're pretty much going back and contaminating it again. Most often than not, if you do anything to the surface after plasma treating and before bonding, you're going to actually hurt the process more than help. That being said, there are some applications. We talked about machining oils on stainless steel parts earlier, where it's simply such a level of contamination that you do need to use both processes to get good adhesion. So in those types of cases, we do recommend any kind of wiping or solvents or primers happen prior to the plasma. Plasma should always be the very last thing you do before you put the ink or adhesive on the surface.
Okay, we've got a question. Why would, and how do you solve, certain color inks that release from a treated HDPE surface after an extended 12 to 24 hours of being wet or actual water or condensation? That's a really good question. Interestingly, it's something that we've seen in the field before where, particularly with ink on HDPE or different polyethylenes, where it will release. We've tried some different things to enhance adhesion there. To really answer this question, it's probably best to see samples and do some testing in our lab just to verify what the right answer might be for this question, just because different shaped objects, different style objects may require different solutions for that.
We've got another question about overmolding. Can these processes be used to aid in the adhesion of plastic overmolding, such as a TPE on an undermolded part? The answer is yes. Molding is another application that we work with. You still need to create a prepped surface for good adhesion. So we treat it exactly the same as we would any other application. So if you are working with TPE, that is something we have successfully treated in the past. We recommend taking a look at plasma. Of course, any other type of plastic as well, but overmolding is another application we've seen. Another question we've got is, will plasma work on aluminum extrusion prior to paint? Yes, there's two technologies that will work great on anything that's conductive, both the blown ion plasma and the flame plasma systems. Aluminum is a very slick material, so it's obviously it's a cleaning and it's also a functionalizing, that micro-etching. To the naked eye, you're not going to see a difference after treatment on aluminum, but on a microscopic level, you actually are going to see that the surface has been etched. So basically, you're creating more surface area for that paint to adhere. So that would be a very good application for flame plasma or blown ion plasma. Another question is in regards to overtreating with flame on H2PE. Yes, you can easily overtreat with flame as well as plasma. So it's same rules apply as before when we were discussing overtreatment.
Sir, I think we've got time for one more question. And the question that I've got for you is, can you see a visual difference of the treated versus non-treated surface?
Thank you. I'll take that one. So our goal is to not change the product that you're working with. We don't, especially when you're working in the decorating industry, it's very important that we do not visually change anything about the product, because it's very important that you still have, everything intact after treating. So the best way to determine is to what we can do so that we do not visually change the surface is to run a trial. I will say there are some systems that tend to visually change the surface. So if it is very important to you, say we're applying a pad printing application versus painting it, and it wouldn't matter what the surface looks like, please let us know that. It's very important. We will make sure we take that into consideration when we run your lab trial, and make notes if we do for any reason visually change the surface of the product. One example of this would be a very shiny plastic, let's say a logo on a cup application. We know there are certain technologies that are very good at treating for pad printing, but not taking that shine or making any marks on the surface.
Great, thank you, Sarah. We appreciate all of you joining us this afternoon. If we did not get to your question, please be assured that either Sarah, myself, or one of our colleagues here at Intercon will reach out and personally answer each one of your questions. Again, the webinar will be available within 24 hours on Plastics News website. Thanks again for joining us, and have a great afternoon.